Okay, so let's take a look at how we can implement the idea of inheritance in a Python program. For this video, I'm going to assume that you have a basic sense of what object-oriented programming is, that you can create classes and then make objects from those classes and interact with them. I'm also going to assume that you have a general sense of how to use encapsulation and that you recognize why we do that. In this series of videos, I'm really not just trying to go over the mechanics of how to do these object-oriented techniques in Python, but I'm really trying to show the object-oriented programming perspective. And so we do encapsulate our objects here, and we're going to use inheritance in a way that an object-oriented programmer would use inheritance, which might be different for some people who have a lot of Python background without OOP. So with that, let's go ahead and jump in and take a look at some code. I have put together a basic implementation for a bank account class that we can use to explore this idea of how inheritance works in Python. And I'm not going to linger on the basics of what I've done here, but I will point out a couple things because I know some folks probably are new to OOP, even if they have some Python experience. So our bank account class has three fields or three attributes that we've implemented. We've got an account number, we've got the owner's name, and we've got a balance. And I'm saying that when we create or instantiate an object, we're going to provide the account number and the owner's name, and the balance is going to start at 0. I have also implemented this using encapsulation practices. So if you're not familiar with this naming convention, you can go back and look into that. But I've got some getter methods for all three because we need to be able to access and find out what all three of these values are. But the only one that has a set method is the owner name. I figure you can't change the account number because that's presumably used inside of a database and is probably untouchable. We don't want to break any connections there. And the balance, if you want to change the balance, we have methods for that. So the only one that you can change, I figured sometimes people change names, they get married or they legally change their name, so we have a set method for the owner name. And then I'm going to collapse all of those up just to save a little bit of screen real estate here. I have also then, outside of the class, I've made just a little print account method because as I test this, I'm going to want to print out what this looks like, and I don't want to have to copy and paste that code over and over again. It just prints out those three pieces of data based on an object that is passed in as a parameter, right? So I'll fold that up as well. And I've got one line of code here that instantiates a bank account object. I've called it account1, and then I'm going to go ahead and print that out. So let's go ahead and run this and see how it looks. Okay, always hard to see, I think, on these videos, but I do have output that matches what I've set up here. So I think our basic class design is ready to go, and we can jump in and start looking at inheritance itself. Okay, we're going to take this idea of a general bank account and we're going to use inheritance to create specific sort of versions or types of a bank account. So for example, a checking account could be one type of a bank account that passes the is-a test that object-oriented programmers like. So a checking account is a bank account, so that sounds good. We could also have a savings account. We could potentially have loan accounts. There's all kinds of accounts that are bank, obviously. But we're going to start with a checking account. So a checking account is going to be a type of bank account. I'll start with a class statement, and I'll give my class a name, checking account. And so far, this looks just like the syntax we're used to. The way we want to indicate that this class extends bank account is with parentheses, and then we're going to reference the superclass name, so bank account. Okay, that tells Python, the interpreter, that this class needs to start with the bank account, and then we're going to add from there. In fact, if we just we'll put in the keyword pass, which which is just sort of indicates that we're not going to put any code there. It's kind of a placeholder. And I think at that point we can actually change our instance to a checking account, and this should run without any problems. Okay, again, probably hard to see, but it still ran. So we were able to instantiate a checking account object. It turns out that this isn't a very interesting case of inheritance because it doesn't actually add anything yet, but we can go fix that. So we'll go ahead and begin with a definition for a constructor, as we typically do. And I'm being careful to type this all out manually because Visual Studio Code, you'll find it helpful. It's going to do some of this stuff for you, but I want to talk about it as I go. So okay. So this version of our constructor now needs to indicate that we're going to, first of all, inherit all of those attributes from up above and methods as well, and then adds on whatever we want to add on. So we're still going to need the account number, and we're still going to need the owner name when we create those objects, right? What we're going to do now is we're going to call and we need to make sure those, back up here. We need to make sure that those values get placed appropriately into our variables up above, our fields. So we need to still run this constructor for a bank account. And the way we do that is using the super keyword, which, as the name suggests, references the super class. So we're going to explicitly call the constructor for that super class, and I'm just going to pass in account number. See how I wrote it there, account num, and the owner name, as we did before. And then I'm going to add a field, add an instance variable. The not very impressive example I came up with is last check number. We're going to keep track of the last check number that was written on this account because I just want to keep this sort of simple. I don't want to get into having to do complex or intricate implementation. So this is just as basic as it gets. We're going to say when you open an account, you're starting with check number 1, and every time you write a check, we're just going to increment that number. Okay, so at this point, I always like to run and make sure I haven't introduced any bugs, and so far so good. My print account method doesn't say anything about a last check number because that didn't exist when I wrote it. And I suppose I could go up here and just modify that. But I'm thinking ahead and realizing this method is probably useful for other subclasses that I create. If I make a savings account, I want to be able to use this as well. And so I don't want to add things that aren't going to exist in a savings account. So I could make a whole new method. I could put the print method as part of my class or something like that, but I'm just going to take a real kind of simple approach here. I'm going to print the account information as usual, and then I'm just going to print the last check number as a separate line of code. So last check number. Sorry, it's hard for me to type and talk at the same time. So this is going to be account 1 dot get last, oops, and so I won't delete this mistake because it's a useful one to make. I don't have a method to get last check number. I skipped a step. So remember practicing good encapsulation. So I'm really not supposed to just access that variable. I started to type out that I'm going to call a getter method, but I haven't actually written one yet. And so this is a good reminder that even if you think your instructor is smart, he's not necessarily. If he's me, he's not smart. Your other instructors might be. And now I'm really getting off the rails as I'm a little flustered here. So I need to make a get method here. So get last check number. It's trying to guess because I've already tried to reference this down below. Get last check number. Kind of an unwieldy name, but again, trying to use conventions that are useful here. And this works just the same as our other getters that we've created without inheritance. So, so it's just going to return self dot last check number. Okay, I think that should get me back on track there. I'll kind of linger here for a moment if you need to see what I did. It's these 2 lines of code. I'm tempted to say sorry about that, but I think there's value in seeing me fumble around with this stuff on some level too. Okay, now I think we're ready to go. Let me run this and see if it prints out a last check number. It does. It says that my last check number is 1. And actually, I sort of ruined the moment there. I almost feel like this should be a place where we applaud or something, because we've now got inheritance and we've demonstrated all of what we need to do basic inheritance. I've extended the class. I've inherited those variables and methods. I've added my own variable to the subclass, and I've added a method to the subclass. We will go ahead and play this out with just a couple other little things. I think it would be nice if the checking account does something besides just give us the check number. So we'll have a method to write a check. And so when we write a check, we're going to have an amount, and it's really going to be kind of the same thing as a withdraw method. And so some of you who are clever might realize, well, I could maybe just call that withdraw method and then do my other stuff, but I'll leave that to you to experiment with. That's probably how I would write the code if I weren't recording a video of it. But I'm going to say that now the balance is going to decrease by the amount. Okay, and that's the part you could just call the withdraw method up above. But the other thing that happens when we write a check is we're going to increment that last check number. So self last check number plus equals 1. Okay, now to test this, I'm going to have to call that write check method. So I'm going to account1 dot write check, and I'll say this is going to be a check for $50. The 00 is irrelevant, but just for visually making sure we know it's money, that's maybe helpful. And now I'm going to, I hate to admit it, but I'm going to copy and paste those 2 lines of code. We don't like to copy and paste often because that's a sign that maybe we should be using a function. But we're going to print out the account as it is created. Then we're going to write a check for $50 and print it out again to see what it looks like after that method has been called. And for this one, I'll spread this out and kind of show you what we're looking at here. So at first, the account number, the name, and the balance was 0, and the last check was 1. Then I wrote a check. Account number and name haven't changed. The balance has gone to negative $50, and the check number has gone up to 2. So that seems to be a sign that our code is working the way that we hoped. This opens all kinds of ideas here that, for example, when we write a check or when we withdraw money, we probably should have code, an if statement that checks to make sure that confirms that we have enough money. So all of that can be coded into these methods. This is really just intended to, again, be a very basic example. The only other thing I wanted to show was maybe a second subclass, a savings account. I won't make you watch me type it. I'll use the magic of video editing to instantly cut and show you what a savings account might look like. Okay, so it never fails. When I stop the video and go to type it, I typed it pretty much without any mistakes, and you could have just watched me type it really quickly. Whenever I say I'll run it, then I make all kinds of dumb mistakes and feel like an idiot who doesn't know what he's doing. So I have created a savings account class here. I have added a field for interest rate, a getter for that, and then a calculation to add that interest rate onto the balance. I don't know that we need to linger on this stuff a lot because the point's not really the math. But what I did then is I drew a little line in my output. I wanted to keep this output up above because I also want to make sure I haven't broken anything elsewhere in my code. But then I'm going to create a savings account And in order to create a savings account with that constructor, I do need to provide an interest rate. Okay, so I guess I should maybe point that out. I wanted to show an example of if we have an additional parameter in our constructor. Notice that I don't pass that into the superclass constructor because it won't know what to do with that. So the idea of a constructor is to assign values to all of our variables. Well, this one assigns values to the 3 variables that it has inherited, and this line of code assigns the 4th. It actually defines and assigns it, right? Okay, so I create an account. I start off with $100 in it because I need to have some value for the multiplication when I calculate the interest. And I picked 100 because even for somebody who's not good at math like me, even I can figure out what 3.4% of 100 is when I run this. So I'm going to print out what the interest rate is. Then I'm going to call the method to add interest, and I'm going to print out my account information again. So let's take a look, see if I succeeded. And up here is my, my original checking account. And down here is my savings account. So I can see that we had a balance of $100, an interest rate of 3.4%. And right here is where I then added that interest rate. So print it out again, and we have $103.04 because 3.4% of 100 is $3.40. So not a very thorough test, I have to admit. But for the purposes of this video, I'm confident that, that this is a good place to stop. My code seems to be working well. As always, reach out if you have any questions about what I've gone over in this video.